So a vector is a quantity with both magnitude and direction. It's a two-parter. A quantity with both magnitude and direction. What else can I say? It is written in textbooks. You'll see, let's say we have a vector v. V in textbooks is written boldface, is a vector. Or you could see it written as v with an arrow over top of it. Or it could be a bold v with an arrow over top of it, just to make sure you know it's a vector. And this can be written as angle bracket, the x component of the vector, comma, v sub y, the y component of the vector. Ooh, Kai, you weren't here for this, were you? 10th grade mechanics. No. Kai, were you in mechanics? Yeah. Okay, yeah. Cool. I write a quantity with both magnitude and direction. Man, that works. Scalar. What's a scalar?
A magnitude that has nothing to do with direction.
Yeah, it's just a number. Just a number. Boom. And you've been working with these your whole life. 7. That's a scalar.
Wait, so
Pi.
7 plus 4.
Any number that's just a number. It's just a number. So how about we'll say a vector, magnitude and direction. We'll say it's an arrow. A vector is an arrow. There's a length to the arrow and it's pointing in a certain direction. So a quantity with both magnitude and direction represented by an arrow. Represented by an arrow. So a vector will look like this. Here's the little arrow over. Oh, in one direction. Good question. Yeah. As a tip and a tail. It's headed in one specific direction. So in mechanics class, we said velocity is a vector and speed is a scalar. Because speed is 20 miles an hour.
Does that have anything to do with space? Or like direction? Doesn't have like 24 miles per hour, it's not like pointing anywhere.
Right.
Yeah,
Or a
20
velocity.
miles per hour anywhere.
Velocity, you could say 20 miles per hour north.
But the second you put a direction on it,
Then it becomes a vector. Yes.
You know, with anything, not just speed. Though, right?
Yes. So there's velocity and acceleration and displacement and all kinds of things that are directed forces and like the wind. I wonder if they do that. I think you ever watch the Weather Channel and they'll show the map
And the arrows.
and then there's like you'll see like
it's
like the storms coming in.
They show you.
yeah.
with surfing too, you'll see like the swells coming in.
Okay, cool. Yeah. So this is a vector field where they're showing kind of a whole bunch of little vectors. They're so cute. Kai, did you have a question?
Oh yeah. So if vector can represent like the speed and direction at the same time together, then it's scalar speed.
Yes.
Oh.
Or anything. It can be like scalars like 7 candies.
Or weight.
Yeah,
8
weight.
pounds.
Yeah, just a number without a direction. So yeah, mass and weight, volume, stuff like that. Those are scalar quantities.
Well, pressure.
Yeah, pressure could just be a number. Yes.
When it's scalar, so is 7 numbers or 7 with the units or no? Like 7.
The units don't change it.
Okay.
So 24 is a scalar and 24 miles per hour is a scalar.
Oh, okay.
So the units don't change it, but once you give it a direction, then it becomes a vector. Yeah. Okay. So there's the definitions. And now let's get a little more specific with vectors. And most of you, except Kai, have seen this, but you're going to see it again to freshen up a little bit. So let's say we have this arrow. This is a vector. And we'll call it V with the little arrow over top of it. We can break it down into its x and y components. This is the sum of its x component plus its y component. So the length of this, we could call it Vx, V sub x, and the length is just a scalar. The length of this is just a scalar. But when we combine them, when we get an angle here, we'll call it theta sub v. Right, the vector angle. And then there's a 90-degree angle here. And then the length of this thing is the magnitude. The length of your arrow is the magnitude of the vector. And it looks like absolute value, but that means magnitude. So we should write this. This means magnitude of the vector, i.e. the length, i.e. that means that is. It's Latin.
That's always weird.
Yeah.
For example, i.e.
Well, i.e. means id est.
Yeah.
It means that is. So that is the length. Yeah, magnitude of the vector.
Id est.
I.e. the length of the arrow. Okay, so remember right triangle trigonometry?
No.
Yeah.
Remember that? Many moons have passed, but yes. We can take the sine of this direction angle. Maybe we should call that thing, we should label that. This is called your direction angle. Theta sub v is your direction angle. So if we take the sine of your direction angle, it's going to be opposite over hypotenuse, which is what?
Vy over v, or v sub y over the magnitude.
Over the magnitude of v. Excellent. And if we wanted to, we could multiply both sides by the magnitude and move it over here, couldn't we?
Yeah.
Is that alright? Can I do that, Maya?
Yep.
Okay, so I'm going to multiply both sides by the magnitude, and then it's just going to come over here. So the magnitude times the sine of the angle, the direction angle, equals the y component. And then how about we do the cosine of the direction angle? What do we get?
V sub x over magnitude.
Over the magnitude. Same thing, let's multiply both sides by the magnitude, move it over here. And so now, if they use this word resolving a vector into its components, so to resolve a vector into its x and y components, you're going to do this. The vector is angle bracket, is how we represent vectors, not regular parentheses. It's an angle bracket. The x component, so check it out, it's Vx comma V sub y. But this is also, we just found out that Vx is magnitude cosine theta. So magnitude V times cosine of the direction angle, comma, the V sub y is the magnitude times the sine of the direction angle. So magnitude V sine of theta sub V, close angle bracket. So this is your vector in its x and y components. So this should be somewhere written in your notebook with a box around it, smiley faces, stars, highlighted, scratch and sniff.
So all those things equal the vector.
Yes.
So
The
those-
vector is made up of the x component plus the y component.
Okay. And we found that each of those, the cosine theta sub
Is this one
b,
formula?
that equals the x component, and the other one equals the y component. So we're just putting those in. Okay.
Yep. Sine is y. Y, sine, sine, y. Sine, y.
Cos
Y, sine.
x.
And cosine is x. Yeah,
No, yeah.
we'll just remember that. The sine is y. Groovy, man. So, bless you. Let me throw up an example. Let's say we have a vector that is 5 meters at a 60-degree direction angle. Let's call this vector V. If we wanted to break it into its x and y components, we could use our formula.
And magnitude would be the 5 meters, right?
Mhm. So magnitude times
Cosine
Cosine
60
60,
comma
5,
sine 60.
and if you type that junk in there, you will soon find that's probably 2.5
yeah. Wait.
comma, and that's
Wait, how do you know that x is 5? 4.3. How do you know that x is 5 though?
Because the one.
5 cosine of 60 is the x component, and 5 sine of 60.
On the graph, how do we know that x is 5?
X is not 5.
Magnitude.
The magnitude, the length of your arrow is 5. The x is going to be here. This is your x and this is your y.
Oh, so sweet. Now I just found them.
Right, so the x is actually 2.5 and the y is about 4.3. This is exact, this is approximate, but yeah, that'll do.
2.5.
Man.
Looks fancy.
And now, yeah, it looks real smart and stuff, but it's not too bad.
It's just how you write vectors.
Yeah, it's super impressive.
Yeah.
You can be like, Mom, look what I'm learning. She's like, wow, that hurts my brain. But it's a right triangle. You know what I mean? It's not a big deal.
This is probably
Yeah, check your mode on your calculators. If you're not getting this, you're in radian mode, not your mode. So a quick note about how to add vectors together or subtract them. And again, we started this last year in mechanics. But let's say we have a vector that looks like this, called u, and a vector that looks like this, called t. And I said, hey, show me what u plus 2t looks like. And so that would look like this, u, and then you start from, so first you do u, and then from where you left off, that's where you add the plus 2t. So here's a t, and here's another t.
Oh yeah.
Right, so this is 2t here. And then so your resultant vector starts from where you started and it stops at where you stopped. Right, so this here is u plus 2t. Right, so you add them tip to tail. And I always think of it as like you do what this arrow wants you to do, and then now you're standing here, and then you do what the next stuff is, right? Because some people will try to do u plus 2t like this, but I mean that doesn't make any sense to me.
So you have to follow the arrow.
Yeah, follow the arrow, bro. Like that's what the arrow is for. Follow it. Come on, what are you new? So yeah, follow the arrow. That's how you add them. So we don't have a lot of time
Unless you
right
subtract
now.
them, then would you not follow the arrow?
Oh, so when you subtract them, okay, good question.
You go backwards.
You just
Yeah, you're gonna go
follow the
backwards. So let's subtract. Let's do half u minus t. So here's u, so I'm going to do half of u. That's about half. Half of u. And then plus t would be this. So minus t is going to go backwards.
Oh, it just goes negative.
The opposite direction.
Oh.
It's still tip to tail, but now you're just going to go, right, because negative t, negative means backwards. That's the direction. 180 degrees the other way. So this is negative t, and then your resultant vector, start, finish, this is a half u minus t, right there. If we had v is 3, 4, and r is 8, negative 2, what do you think v plus r is?
3 plus 8, and then
11.
4 minus 2.
So 11 too.
Yay, rocket surgery. So, check this out. Yeah, number 1, there's 11 meters, and this is 49 degrees. Hey, you guys, the direction angle, point your face at me.
Oh, it's
The
above.
direction angle is always from the positive x-axis. It always starts here. So what's your angle actually equal to?
90 plus 49, so 139.
Yeah, so theta is 139. If you don't do that, your whole life is wrong. So, so now, if we want to resolve this vector, it's going to be 11 cosine 139, 11 sine 139, and you get the right answer. How about if it's, how about something like this? What is your direction angle?
Oh, it goes all the way around?
You could do that, or you could do a negative angle.
Oh,
If we rotate down, what would the negative angle be? It sounds crazy, right?
Negative angle.
Yeah, so this could be a negative 20 degree angle. I guess that's a little crazy though, isn't it? Maybe we shouldn't get all loco.
How do you have it?
Wait, I'm confused.
Okay, sorry, I just ruined you. Okay, so let's start here. Let's rotate 90, 180, 270, plus another 70 is 340.
Okay.
So your angle is 340 degrees.
No, that's realistic.
What actually is, it's just
Oh,
not,
because you're not doing triangles anymore.
yeah, it's not a triangle. So you can rotate by 340 degrees.
Never mind.
Yeah, that looks real.
Yeah. But so if you do 25 cosine 340 and 25 sine of 340, you will get the x and y components here that make sense.